A rectangle is to be inscribed in a semicircle of radius 2. What is the largest area the rectangle can have, and what are its dimensions? So let's go ahead and draw us a picture, and we will make a semicircle of radius 2, and we want to inscribe a rectangle in this semicircle. And so it looks like this could be x, x, and y. So the area of our rectangle is going to be 2xy, and we are interested in finding the largest area. So we'll be wanting to take a derivative here and looking for a maximum. But first, we need to express this as just a function of x or just a function of y. And our connection is this xy is a point on this semicircle. So if we had a circle of radius 2, the equation would be this. Solving this for y, we would have 4 minus x squared square rooted. And we would normally put a plus and minus, but this is the semicircle. We want the upper half, so we don't want the negative. Now, that is y in terms of x, so we could put it in for y right here, and we would have the area equals 2x, and then 4 minus x squared to the 1/2. We're expressing that radical as a rational exponent because we're going to want to take a derivative, and having that as an exponent, we can see the power rule there. Now let's go ahead and find the derivative of this area function, because we are then going to look for critical numbers because we're after the maximum. And this is what we're taking the derivative of. We need to apply the product rule. So we have the first times the derivative of the second. That's going to be a power out in front. Decrease the power by 1, multiplied by the derivative of what's inside. So we have a power rule, chain rule. And that's just the first part of the product rule. The second part of the product rule is second, which is 4 minus x squared to the 1/2 times the derivative of the first, which is 2. Now we're interested in where this equals 0 so that we can find any critical numbers. Looks like we can reduce here. And this is going to be negative 2x squared over the square root of 4 minus x squared. So we're going to move this to the other side and have 2x squared over the square root of 4 minus x squared equals, looks like 2 times the square root of 4 minus x squared. So let's go ahead and multiply both sides by 4 minus x squared. That will get rid of this here, and we can reduce each of these by 2. So it looks like we have x squared equals 4 minus x squared. So moving this over to the other side, we have 2x squared equals 4. X squared equals 2. So x equals plus or minus square root of 2, but we only want the plus because we're seeing that we have a length here, and so x is the square root of 2. Looking at our function, our domain, because we have this radical, looking back up here at our area function, our domain is from 0 to 2, and if I put in 0 or 2, I get 0, and any other value I'm going to get a positive, and so we know on that interval it will take on its maximum, and we found that maximum. It's when the x is the square root of 2. So if we put square root of 2 up here for x, it looks like we get y equals the square root of 2. So the dimensions of our rectangle of largest area are going to be 2 square roots of 2 by square root of 2, because we need 2 of these x's for the length by that height or width here, which was y, which was square root of 2.